Uh, Hi, sorry I can't be there in person, but I'm delighted to see this event happening. So I'd like to first start by thanking Peter, the Creative Living Lab, the University of Applied Science and Arts, the Gebert Roof Foundation, and remember Simone Schweikert for making this possible. Uh, I'm Neil Gershenfield. I direct Center for Bits and Atoms at MIT, and I wanted to take just a few minutes to help you understand what FabLabs are, what this project is. So as background, one of the research program works at the boundary of computer science and physical science. And one of the core themes emerging is the idea of digitizing fabrication. So telephones used to be analog, they became digital. We can now talk by video. Computers were analog, they became digital. You have the computer in your pocket now. But manufacturing is analog, meaning there's no information in the materials. You can cut it or print it, but the materials are dumb. But that's not how biology works. You're actually made out of programs. Your materials contain codes. And so one of the research themes is how to digitize fabrication, meaning not just a computer connected to a tool, but the computer is a tool. And a program doesn't describe a thing. The program itself is a thing. And so in 20 years, we think that'll lead to the Star Trek replicator. In 20 years, we'll make a machine that from the atoms on up can build anything by building digitally at a molecular level. FabLabs began as an outreach from that project and then unexpectedly spread around the world. They've been doubling every year. There are about 50 now and maybe 50 coming from the bottom of Africa to the top of Europe and from furthest west to east. So to understand, in our lab at MIT and labs like that, we have tens of millions of dollars of tools. And in 20 years, we'll make the Star Trek replicator. And the Fab Labs are in between. Just like in the history of computing, there were mainframes, then mini computers, then hobbyist computers, then PCs. And email, the internet, businesses, all the things you do with computing really emerged in the mini computer era. They weren't cheap enough and small enough to go in your pocket, but small groups of people could use them. So in the same sense, there's a research roadmap from connecting a computer to a machine to make something, to the machine able to make a machine, machines that make machines, to building with codes and materials, and ultimately to self-reproducing materials. And the Fab Labs are an outgrowth from that project. So with the tools around you, you can create most of modern technology. You can't go below about a millionth of a meter. So you can't yet make integrated circuits. And you can't yet make things, say, quite as big as a jumbo jet. But in between those ranges, you can create modern technology. And the labs aren't frozen. They're continuously evolving towards this goal of self-reproducing machines. So when you come to the Fab Lab, you can make a new Fab Lab. But as the labs have been spreading, what we're finding is you don't have to wait 20 years for the research to explore the impact of what happens if anybody can make anything anywhere. And so that's leading to the Fab Lab network spinning off a nonprofit foundation, a for-profit fund, a degree program. So the .org nonprofit side is aid. The idea that one of the most empowering kinds of aid is not sending solutions, but giving tools for invention, widely available. On the businesses, one of the really interesting opportunities is you can use the lab there to invent products for new businesses. But even more important, once you're linked to a global network of these tools, it means once you're done, you don't have to ship products to market, you can ship data and have products be produced on demand locally, where everything produced is custom and different. So somebody can design something somewhere in the world and you make and sell it there, or you design something there and you ship it all around the world with local production. And so it's really kind of a new industrial revolution, similar to how software evolved, the ecology of software markets, where it's an entirely new way to think about creating businesses and jobs, not just by prototyping, but by making the prototype in the product in a global network. And the educational piece is very exciting. We have amazing kids, young girls, boys, retired people, all ages, coming through the labs, mastering skills far beyond their local school system. And rather than the traditional answer that you have to leave now and go far away to go to an advanced school, in the labs are tools to create technology. Libraries are certainly online. And through the video network we're now using, I see Peter more than many of my colleagues at MIT, because on campus we're too busy to talk to each other. But through the video network, we collaborate. And so we've launched classes, a Fab Academy, which is not distance learning from a central site, but a networked campus where the whole Earth becomes the campus and students and work groups in the labs are part of that, really kind of making an internet of education that you're now a node of. So you have a great new resource in your community. Don't view it as frozen. View it as a window into this research roadmap as the technology evolves. But more than that, it's a window into how do you bring aid into communities? How do you teach advanced technology and design? How do you incubate new businesses, both done locally in Lucerne and connected into this global network to share people and projects throughout this lab network? So I'm delighted to welcome you to it, and I look forward to visiting you in the lab in Lucerne. Thank you.